Let's move on to the next method in under food. It's called improved rice cultivation. We will look at one dominant method called system of rice intensification, which is being discussed a lot, even though not everybody is bought into it. We'll see that. So in terms of ranking, we will look at improved rice cultivation, which is at number 24. We'll make a brief point about how this is done. With 11.34 gigatons in reduced CO2 by 2050, with no additional costs required, you have a net saving of $519.1 billion. How amazing is that? And then the system of rice intensification is ranked at number 53, which reduces 3.13 gigaton in CO2, which includes methane as a CO2 equivalent. No additional cost required again, and a benefit of $677.8 billion. So typically rice is grown into a seedling, and after about 3 weeks it is bunched together like this and transplanted into a rice paddy. That's been the traditional method. Accidentally in Madagascar, a Jesuit priest, Lalaune or some French name, found out when the students made a mistake and planted them early at 8 to 10 days instead of waiting 3 weeks and maybe planted them individually. They discovered that actually the yields went up and there were many other benefits. When you hear about rice, you think about tropical countries which eat a lot of rice, and that means flooded rice paddies which are emitting a lot of methane. So look at that. You have beef way up here, of course, with as much greenhouse gas emissions as methane, and then they have we have chocolate, coffee, prawn, and so on. Down here is rice with a total of 4.5 gigatons, I think. Yes, kilogram CO2 equivalent per kg of product. Excuse me. That's the contribution of rice to greenhouse gases and methane. So obviously we can, if you can reduce it, that's great. Sorry about that. So the system of rice intensification is not the only approach to sustainable rice production. We will see what the other methods are, but it seems to be the most promising. Kumar from Northeast India and his friends engaged in a set of practices knit together in a compelling way, where they reported some world record rice yield per acre in 2012 or so, I think. So I will show as a figure this again, but you have 3 steps: planting, watering, and tending. So rather than bedding out 3-week-old seedling by the handful as we saw with the guy carrying on his shoulders, bunched close together, SRI calls for transplanting single seedlings when they are 8 to 10 days old, and using a square grid that gives each one a wider berth. Doing so creates more access to sunshine and canopy space above ground, which improves light harvesting, evapotranspiration, and yield biomass, and more room for roots to spread below. Okay, watering. Most conventional rice fields are continuously flooded, enabling methanogenesis. So when you have a wetland-like situation, organic matter that falls or the weeds that are dying are consumed by anaerobic microbes which produce methane, especially in high temperatures. But SRI specifies more purposeful intermittent watering, temporary draining midway through a growing season, or alternating between wet and dry conditions is more favorable to soil microbes and root systems that like to breathe, while disrupting the waterlogged conditions that methane-producing microbes favor. Research shows mid-season drainage alone reduces methane emissions by 35 to 70%. Tending. Weeds can be a challenge in the absence of flooding. So most of the flood irrigation of rice paddies is done to take care of the weeds, which are drowned by this method, and rice plant, which is very vulnerable to weeds, is protected this way, which This weed problem is addressed by SRI with a rotating hoe used by hand, also aerating the soil. In tandem, applying organic compost helps to enhance soil fertility and carbon sequestration. Reducing or avoiding synthetic fertilizers protects both soil and waterways. Okay, so this is from Cornell University's website on advocating SRI. So here it is. Carefully transplant a single seedling at a time at a two-leaf stage, which is 8 to 12 days, unlike the traditional 3 weeks. Plant seedlings at a distance of 25 centimeter or more in a square pattern, as you can see the grid in which the ladies are working. The soil is still very wet. It's not flooded, but it's still very rich in water content. Keep soil moist and aerated. Fertilize with compost. Add chemical fertilizers only if needed. So this lady here is walking with this rotating hoe, which aerates the soil and removes the weeds and solves much of the problems when you don't flood to remove the weeds. From a FAO site, based on these references, the reported benefits of SRI include increase in yield per hectare, increased net income per hectare, impressive number there, reduction in cost of production, reduction in water requirement as you can imagine, shorter time to maturity, another surprise finding, protection against biotic stresses, pests and diseases, very good byproduct, co-benefit, tolerant to abiotic stresses like drought, storm damage and extreme temperature, which is a concern with global warming, and higher milling outturn by 15%, which reduces the chalkiness of the rice, which is very important for consumers. So rice has served as a staple diet for millennia for many of the tropical countries, and now consumed in even in temperate and high latitude countries, obviously. Tastes great, right? So not everybody agrees with these numbers because it's not as extensively published in peer-reviewed literature, but the proponents of SRI would say that academics are not accepting the results basically because the method didn't come out of academic research. Well, whatever it is. Mitigation of climate change from SRI is methane emission from rice fields determined mainly by water regime and organic input. So reducing flooding would reduce methane output. Flooding causes methane emissions, so organic inputs stimulate methane emissions as long as fields remain flooded. So the fertilizers actually favor not only rice yield but also methanogenesis when it's flooded. Mid-season drainage and intermittent irrigation can reduce methane emissions by 40% by the IFPRI report estimates. Keeping soil nearly saturated in nearly saturated conditions may promote N2O release. Okay, 15 to 20% of the benefits gained by decreasing methane emission was offset by the increase in N2O emissions under SRI. Soil organic carbon declines after a shift from flooded system to non-flooded system. So the wetland conditions and the anaerobic respiration and so on reduce the respiration of hydrocarbon, so carbon sequestration goes up, and that can be obviously recovered partially by using the rotating hoe and reducing weeds and increasing aeration and so on. So obviously you have to worry about that. As for other methods that we mentioned, SRI is not the only means for achieving improved rice production. There are 4 general and increasingly common techniques best used in combination that focus on water, nutrients, plant varieties, and tillage. So there are rice plant varieties now which are better for rice production in terms of yield increase, methane reduction, and so on. Mid-season water drainage and alternate wetting and drying improve aerobic conditions. So that means they reduce methane production. More balanced application of both organic and inorganic nutrients reduces methane emissions while supporting yields. Rice varieties or cultivars that are less water loving can be used in more aerobic environments. So when you have non-flooded systems, cultivars that require less water themselves. Rice is almost 90% water. That's what we always say. When you boil it, it fluffs up, and if you squeeze it, a lot of water would come out. Techniques for seeding rice without tilling the ground also have positive effects. So those are the improved rice cultivations without the rice intensification system, or what is referred to as the Madagascar rice, because the Jesuit priest discovered this method accidentally in Madagascar. Impacts. Our analysis includes both SRI and improved rice production, which involves improved soil, nutrient management, water use, and tillage practices. SRI has been adopted largely by smallholder farmers and has much higher yield benefits compared to improved rice production. We calculate that SRI can expand from 8.4 million acres to 133 million acres by 2050, both sequestering carbon and avoiding methane emissions that together total 3.1 gigatons of carbon dioxide, and its equivalent over 30 years. With increased yield, 477 million additional tons of rice could be produced, earning farmers an additional $678 billion in profits by 2050. If improved rice production grows from 70 million acres to 218 million acres over 30 years, another 11.3 gigatons of carbon dioxide emissions can be reduced. Farmers could realize 519 billion in additional profits. So when it comes to going from non-flooded to flooded or flooded to non-flooded methods, the incentivization of increasing yields and profits is important, because if water is made available or electricity is provided for exploiting groundwater, then farmers don't necessarily care about reducing water use. They will just think it's safer to bet on flooded irrigation method and grow rice instead of experimenting with these SRI and other approaches to enhancing rice yields. So profits are more important than reducing methane and reducing CO2 or improving carbon in the soil and so on. So we always have to remember those kind of behavioral issues when it comes to how we sell these methods.